This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome to this series in Mastering Mathematics, program produced by the Ministry of Education and its Broadcasting Unit and ABS Television. I hope that you are now feeling that you are a mathematician in the making. Last time, we were looking at our simultaneous equation, and I'm sure by now you know that you can do them. I was just about to leave this topic to get on to another one. And guess what? I just remembered that there is another topic in our mathematics syllabus that is also calling for students to solve simultaneous equation. But this time it is using a matrix method. So today I am going to introduce you to the topic of matrix. And the plural of that word, because it looks like a Latin word to me, is matrices. All right? So we're going to be dealing with matrix and matrices. You're going to like it because it is so very easy. And guess what? I'm going to challenge my primary school students to follow me because you are going to see that you can do this particular topic too. All right? Now, the first thing, as usual, we start with our definitions. And if we want to know what a matrix is, it says a matrix, it's a rectangular array of numbers or letters consisting of n rows and m columns. But with all that fancy word and everything, what we're going to say, the matrix, we're going to recognize it because it loves to be in brackets. And after that, we're calling certain lines and things rows and columns. So for example, let me make certain that you can see the ink on our boards, okay? So for example, first of all, you see numbers, it could be 2, 4, 6, and we could have 9. As long as it's in a bracket, it is called a matrix. It is usually saying then, when we go across anything horizontal, all right, the horizontal direction we call rows. Okay, so these are the rows, horizontal direction. That is what we call rows. And yes, you know that the Roman empires, they like to build these columns. Okay, we go to Greece and they're building the columns. So anything that is going up in the air, yes, okay, so up, down, these are what we are calling columns. Simple, all right? So, just as if you have your ground and you're going through the ground and you're going through your rows and you say you're walking on the banks because you have to water, those are what we're still calling the rows. So when we transfer it to a classroom, it's the horizontal position that we call our rows. And anything that's going up, you know, like you're building a building and you have your columns going up in the air and you hear them using that specific word, columns, okay? So the same thing, up and down, this is what we call the columns. Because we have these two words associated with matrix, we also have to start talking about the order of the matrix. Because you know, although it's in a bracket, we can put in as many as we want to. All right? So, and then that then gives us order. So that if I have this matrix that I have 2, 4, oh, not so close because it's not 24, so it's a 2, and it's a 4, it is 6, and it is 5. Okay? This matrix, because it has 2 rows, we see that? Okay, so rows 2, and then it's times, how many columns do we have? Yes, 2 columns, okay? Okay, so columns. Okay. It is called a 2x2 matrix. That is where the names come from. The number of rows times the number of columns gives it its order. Okay, so the order of the matrix is the number of rows times the number of columns. So we talk about a 2x2 matrix. Just as how you have your planks, you go to the lumberyard and you're buying these your boards, etc. Same sort of thing. So we don't multiply it out, it's just called 2x2. And then we get into the things, because of course without numbers, without letters, without what we're calling in sets, the elements, we use the same term when we talking about the children of the matrices. We call them elements. So again, this word comes back to us, okay? So each letter or number is called the element of the matrix. In the human world, we would say the children of Estella Weston, all right? In the mathematician's world, we will be talking about the elements of the matrix. Then we have another special term that we talk about, a column matrix. And that's a matrix that just has one column, one number over the other number. And similarly, row matrix, one row that we'd see going horizontal direction. And because we have anything that's equal, yes, we can say it would form a square in terms of a rectangle. We say the same number of rows as columns gives us the name of a square matrix. All right? No, there's not too many of these little technical terms that I want to bore you with, because these are not the main element or the main fruit that we take care of when we're doing mathematics. We're talking about operations mainly. So that is where we want to get. But just from the beginning, we can see then there is nothing new that you would not expect with your matrices, because you're accustomed to columns. Albeit in our algebra, we were just dealing with a one row stuff. So we were talking about something like 12x plus 4y. All right, row. So when we get down to our matrices now, it's more or less two rows, and then that puts us into two columns, and we're talking about a 2x2 matrix. Now, why do we want to talk about these things? Mostly in the mathematician's role in the classroom, formal operation, we are asking you to use it to solve a simultaneous equation. So we're going to start right from the very beginning, because it takes its time using all the operations: multiplication, addition, subtraction. But listen carefully. Matrices says, do not take me into the world of division, because you're just making a joke of me. Division is the same thing as the inverse of multiplication, and I am just staying with my multiplication. So when you talk about operations associated with matrices, we're only using our addition, our subtraction, and our multiplication. And again, you will tell your students, why aren't we using division? Because it's telling me that that is just the inverse of multiplication. So that matrices would ask me not to say 6 divided by 2. So because it says right away that that is the same thing as saying 6 multiplied by a half. So don't give me two stuff at the same thing. All right? So we're going to examine those and see exactly how, when, and where they're used. In the real world, matrices has a fundamental part to play, because you go into those supermarkets and they're asking, excuse me, where would I find a particular goods? And they say, go down the aisle and look at so-and-so. That is all based on the principle of matrices. If you work in the post office long enough and you're sorting letters, you'll see again that it plays a fundamental part in that aspect. And there will be a variety of operations and a variety of reasons. And I want you to Google, send us this, remember our email, What is the email? Yes, it is masteringmathsebu@gmail.com. So remember, if you don't get Karen Weston on the phone, just email. My friends here are waiting to answer your questions. All this is a part of what we call our volunteer programs, because they are prepared to put aside substantial work and to facilitate the public at large to make certain that we can spread content of mathematics. So we get back to our matrices, do a little revision so that we can see that we know the definition, because it's always basic. And my primary school students, I'm specifically not teaching you anything else today, but asking you to follow me, because you're going to see that you can do, in terms of matrices, the addition, the subtraction, and the multiplication, at least the first scalar multiplication that I'm talking about. So what did we say? We are into a topic called matrix. Why did I jump into that topic? Because fundamentally, it is usually asked to add, and it is in the second part question, the last question normally. So nowadays I see that they're giving you only 3 choices. So you may have 9, 10, 11. So it's usually a part of number 11, or sometimes it can be in the compulsory first section, where they're asking you either to add, subtract, and multiply some aspect of a problem using matrices. But specifically in our second section of this question, it's usually asking you several things, building you up to get to the point where you must use a matrix method to solve the simultaneous equation. So while we're in that paradigm, I thought it fit to bring in that right away, and that is really half of our 15 points question. So we are on our way, doing very, very well. Okay, so yes, we know our definition. A matrix, it's a rectangular array of numbers. Okay, plural of matrix is matrices, and it can be numbers or letters consisting of n rows and m columns. The order is the number of rows. And how do we identify the rows again? Right, we say it's horizontal for the rows, and the columns, they are vertical. All right, so then we say the number of rows times the columns would give us the order of the matrix, and we would say 2 by 2, 3 by 2, 4 by 2, 4 by 1, or just 1 by 1. All right, and then how do we say we identify the numbers that make up the matrix? Yes, same thing as in sets. We call them the elements. And then we call these things specific. Column matrix, 1 column. Row matrix, 1 row. Square matrix, same number of rows as columns. So can we ever have more than 2 rows? Sure we can. But for our examination, because we just want to test certain principles and concepts, we're usually limited to our 2 by 2 matrix, doing most of the difficult word. That's a whole mouthful, whole new topic, giving you a chance to get accustomed to what we're saying, giving you a little chance to get something to drink, and to come back again. We'll take a break now.
Be sure that you're working in the same units of measure when performing calculations. If a problem involves inches, feet, and yards, be sure to make the appropriate conversions so that all your values are in the same unit of measure. For example, change all values to feet. When asked to show work or justify your answer, don't be lazy. Write down everything about the problem, including the work you did on your calculator. Include diagrams, calculations, equations, and explanations written in complete sentences. Now is the time to show off what you really can do with this problem.
All right, so we're back. And we're ready now to get into the plane that we love so much, the whole operation involving mathematics. And again, it doesn't matter what topic we're dealing with, What are the operations? What do we do with numbers? We add them, we multiply them, we subtract them, we divide them. But what did we say about matrices? Yes, they're not going to be dealing with any separation between multiplication and division, because in their world they say that division is just the inverse of multiplication. All right, now let us look and see. And again, they are still adapting the same thing as if it was sets, because when we call those matrices, we name them, we use capital letters. So if I had a matrix and it was, so we're going to look at the rule for addition. So we're looking at the addition of matrices, okay? Addition. And we're dealing with our 2 by 2 matrices or square matrix. And I would say if A is equal to the matrix and it is 2, it is 5, it is 7, and it is 8. Don't forget we have to put them in a bracket. They like to be housed, okay? And B is equal to the matrix and it is 3, and it can be 4, and we can have 10, and you can have 13. What would the sum? So we're find the sum of 1, and it is A plus B. And 2, I can ask you for B plus A. Right. Are you prepared to work with me? Now, if we come over in this corner, so my primary school students, how is this operation carried out? Our first thing was to say, since A is equal to, and our matrix would be, because we're copying it from the exam papers, so we have to start stating, we talk to the examiners from our papers. They don't see our faces, they don't know who we are. And so the only thing is to talk for them on our papers. Since A is equal to 2, 5, 7, 8, and B is equal to 3, 4, 10, 13, then A plus B would be equal to, we substitute what A is, so it is our 2, 5, 7, 8, and it is plus our 3, 4, 10, 13. So how is this addition achieved? Well, let us take a look, because our primary school students, this is your simple addition that you're doing in your classrooms, where you would have been adding 3 plus 4, okay? Now we have taken it to another level, and we are looking at it from matrices. First rule says, for addition, the things in the same positions are added together. So if we're going to look at this lovely, nice little diagram up here, the things in the same positions are added together. So if we were looking at our pictorial form of it, it would have been, for our first position, it would be dot plus dot, okay, first position. Second position, yes, it would have been our arrows facing down. So this would have been this plus this. These two would be added together. And then we would get to our red strips. Okay, we don't know what we call them. But yes, that diagram going this way plus this one. Okay, those would have been added together. And lastly, we'd have gotten to something that looks like a lovely pancake or pizza, right? Yeah, small little one. Because Jetta said his belly is not too big, so he doesn't buy big stuff for people, just a little thing. And my singing lark says she doesn't want her voice choked with these things, okay? So that is what we do here, okay? Yes, we have some wonderful people in the studio who make life so easy, and they're so wonderful. It's a joy to be here every time. And they're fast becoming mathematicians too. So when you see them on the street, don't take them for granted. All right. So first positions. Seconds. Okay, seconds. All right. And thirds. Yes. Thirds. Okay. And our fourth position. So it's just a matching. I told you it was simple. Okay? So here we go now. What would we be doing here? I know you're ahead of me a long time. You're finished. Let your mommy get a chance to see, because I know you can do it. So yes, our 2's with our 3's. So it's 2 plus 3. And what? Yes, the 5 and with the 4. So it is 5 plus 4. And then it's our 7 and our 10. So it's 7 plus 10. And then it is our 8 without 13. So it's 8 plus 13. And what is the answer? Yes, it is 5. It is 9. It is 17. And here it would be 13 would give us 21. And that is the answer. Simple. I know you could do it. All right? We are just doing simple stuff and giving them big names. But this is the little thing. When did you do that? Yes, my primary school teacher, Teacher Pepsi, gone to the great beyond. But she had us on the floor with those stoppers. And we're counting 1, 2, 3, 1, 2, 3, 4. And we would have added them. In schools, you put in your strokes. 1, 2, 1, 2, 3. Yes, that's all. And that's why you hear these big people coming out and saying mathematics is difficult. Talk your mind. Somebody gone crazy. All right? So let us just repeat again, because my granny says that she needs to go a bit slower so we can understand. We're given the rule for addition. So we have A is equal to 2, 5, that's our first row, 7, 8, second row. So what do? We pair it again with the members in the first row, 3, 4, and second row, 10, 30. Putting them side by side, we understand from our coloring that the things in the same positions are added together. Okay? And so we come and we treat our numbers the same way. 2 plus 3, all right. 5 plus 4, yes. 7 plus 10, yes. And 8 plus 13. And that's the answer. Bingo. All right? Now, I know that we took you through that. And that was so very simple. What I'm going to ask you to do, construct some for yourselves and see if you can do it. And you will tell me tomorrow, because you can email us to say exactly how you got on with it. Of course, you know my cell number, 783-6971. And I'm always around. If I can't answer you, I'm not going to lie. I'm going to say I can't take your calls at this time. Okay? But keep on doing your mathematics. And remember, the email is masteringmath, matheebu@gmail.com. Because every time and on every occasion, we are going to show the world that when it comes to Antiguans and Barbudans, there is nothing that is impossible, because we believe in God and He has given us the mind, the spirit, and everything to say, behold, I am with you always, and everything is possible. Only believe. We'll be right back tomorrow. See you then.
Join us next time for another in the series, Mastering Mathematics. a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.